Good morning. We are Team iXblue, and our 2021 capstone project is the User Acceptance Test Report tool. Our team was led by two iXblue engineers, Daniel Nugent and Patrick Moran. Our team was also aided by a coding consulting technical director, a recent URI graduate, Nick Rommel. The iXblue team consists of two computer engineers, including myself, Michael McHugh, and Brent Moynihan. iXblue is a French company located in Saint-Germain, France. Our team has been working with the Lincoln branch here in the United States. iXblue works with inertial navigation systems, also known as INS. Because of this, they are a global leader in navigation and positioning technology. What is an INS? Well, an INS is an inertial navigation system that is based on fiber optic gyroscope technology. It functions by calculating relation based on measuring phase shifts between counter-propagating light waves. The primary INS system that we're using in our UATR tool is the FINS Compact series. Because inertial navigation is a growing field, the equipment must be tested frequently and efficiently. The current test tool is non-automated. Our job is to automate it to decrease testing time. The anticipated best outcome of this semester is a fully automated testing tool, a guide for the tool, and software design documents. Our team accomplished many tasks this fall semester, including a working data parser, a graphic interface, sending commands to the INS, and a fully detailed block diagram that includes all software and user-defined things to implement. The economic impact for iXblue is decreasing testing time, which also eliminates shipping to the facility and increases company efficiency. This is applicable to all of the INS devices that we shall be testing with our tool. The block diagram here is a condensed version of the main block diagram, which will be demonstrated later on in the presentation. But this block diagram shows all of the testing procedures needed to create this testing tool. Personally, I, Michael McHugh, worked on the data parser to read log data. Now, I created a Python code that opens repeater data and the flow from the INS, and the script then locates the lines in said data flow that needs to be parsed and splits each string of the data into pieces and converts them to floats. It does this by finding commas in each line of data and parsing it into said lists that contain these datas. Now, the log data is inside the log file that I was given, is represented in these lines of numbers. As you can see, they all have headers and then data that follows. So my code takes each positional data. Here it demonstrates longitude and latitude, and it splits them into two lists and then compares them against each other in this graph that is displayed here. The data parser then takes the stored named lists and plots it using a Python library called matplotlib and places on a GUI using another Python library called tkinter. The GUI, the graphical user interface, is used to display the data that is being parsed from the data fields. The GUIs, for short, have two different functions. The first functionality is an interface for users to select data that they want to see, and the other is to select which data they're actually going to graph. The iXblue GUI that I have been working on is displayed here. On the left, you can see 4 buttons: position, role, pitch, and heading. And when each of those buttons is pressed, a graph displaying the parsed data is shown below. Going forward, I would need to place text inputs on the GUI. I need fog and accelerometer bias graphs, live data manipulation, and email notifications. These are all things needed for the best anticipated outcome of the 2022 semester. Now let me introduce Designer 2, Brent Moynihan.
Hi, my name is Brent Moynihan, and I am the second designer for Team iXblue. One of my first major accomplishments this semester was implementing the block diagram you see before you. This block diagram is a great organizational tool for the team because it allows us to view the whole scope of the project and how each part interconnects with each other. So at the top left, you can see what the INS does itself and the automatic functions it provides. At the top right, we have what the user will have to implement when they receive the software, like input their IP address manually or their latitude and longitude. At the bottom, we see what the program does itself and all the functions we must provide to the software. So every function here is listed for the project, and all we have to do is implement these functions as we go along. And this has been a great tool because throughout the semester we've been referring back to this chart and seeing which functions we can implement at the time and which functions we will need to implement in the future. And if we're ever stuck, we just move on to a new node in a modular fashion, and we can implement those functions in a way that we can connect all of the other functions later. My second accomplishment this semester was being able to connect to the INS device and actually receive data and send data. And so what we used initially for this was Hercules, and this is a program to set up a TCP server to receive data and send. So initially we used this to actually verify that we could open up a data stream with the INS device and see if we could actually send a command. And one of the first commands we tried to send was a zupt on mode, which sets the heading initialization to 10 meters per second or 0, whatever we want to use it for as a testing device. And so after we confirmed that we could actually receive and send data, I started to implement this through a Python GUI, which is what the software will have to be at the end. And so I implemented a start and close data stream function to actually open up the data stream and be able to send functions within it. And we implemented a few functions like the zupt on to see if we actually changed the functionality of the device. And so once we verified that this was possible, the gates are open and we're able to move on. And so this is also a verification that iXblue provides to us. And this is what they use initially for their testing. And so we can see that this is connected to the INS device, and as we send commands, it changes this functionality. And so this is just another verification process to see that we have sent commands and we have changed the functionality of the device. So in the middle right, we sent the zupt command, and this is a before and after pic of it being off and on. This is the condensed block diagram that we saw before again, and most of these functions have been implemented already, and this is just the major functions that we have to. So at the end, the software program will include all these functions, and we've been going through this list and implementing them manually. So going forward for myself, there's a few things I need to do. I need to build an MEA checksum calculator, which is a specific format to check some of the commands to actually get sent to the INS device. So if they're not correct, they won't get sent properly. I have to actually perfect the way we send commands currently, and I must connect my GUI functionality with my partner and start implementing custom design for users so they can implement their own testing devices and testing settings if they wanted to. So for the ABO and our final accomplishments, we need a user guide for the tool to explain how the tool works, software design document going through everything we actually did, software documentation detailing the operation and actually how it connects the INS device and the commands we used, final report covering all the data we collected, all the results, and the suggested next steps we could use for improving the design. And we have to submit our source code and do test itself to make sure the program works. Finally, thank you to everyone and our TDs. We want to thank Daniel Nugent, Patrick Moran, Nick Rommel, and Patrick Liefering for all their help they've given this semester. They've really helped us and have been great mentors, truly. And we wanted to thank Professor Sunak as well and Jack Murphy for all the help they've given us. Thank you so much.